So, ladies and gentlemen, let me introduce our next speaker. John just reminded me that there is a microphone in the middle of the floor right here if anybody wants to ask questions. So this is Dr. Charles Wood. He's a professor and author. He's written several books on several topics. I think that it's important for, one of the things I love about B-Sides the most is that we get a mix of a lot of different people from the government, from corporations, from academia. I think that one of the things that we've been missing up here a lot is people from academia, and that's why I'm so happy that Dr. Wood was accepted for his talk. He provides a lifeline into the classroom for us, which I'm not sure that we have such a good one. So thanks a lot, Dr. Wood.
Thank you. Thank you. Thanks, everyone. Okay. Thanks. Yeah, let me give you a little bit of background on this. My topic on big data and information security ended up being a topic where I consider myself, I teach data analytics at Duquesne University, and I teach information security at Duquesne University. And so I consider myself kind of an expert in both, but they seem to be a disjoint field, and there is really no need for that. So I started delving into, are there people out there applying big data solutions to information security? And I found out that there are some. I started this about a year, 2 years ago, and there are some people that are really cutting edge stuff. I admit that this may not be as technical as some B-Sides presentations that I've given and that I've seen. It's meant to be at a little bit higher level. I try to. I'm not sure how much experience the rest of you have in big data, and if you're all experts in it, then you're going to be bored. But that's where this came from anyway. So the problem that we have with big data is, first off, a lot of us see a lot of data and say, I am big data. You know, if you just look at my logs of intrusion attempts every single day, I get 3,000 a day. I'm big data. And I wanted to bring up a point that because you have lots of data, you're not necessarily big data. You just have lots of data. And in fact, the amount of data that you get might even be, as it starts to increase, might even be a very big strain on your corporations. I know that when I attend the security seminars around town, like I see a lot of you there, the quarterly endpoints where you have to verify all your controls, and a lot of you realize, when those hit, you see people coming to these conferences and they look like they haven't slept, and they're all got the stressed out look on their face, and they say, "Yeah, we have to do all this work at the end of each quarter, and then next quarter it starts all over again, and every quarter it grows." And so they're dealing with lots of data, but you can see a problem like that causes them to even causes them more problems than a solution to the problem. So there is lots of data. The hacking attempts have increased. One Pittsburgh company told me that they get 3,000 intrusion attempts per day, and that I don't think you can put a network online and not start getting like 1,000 per day. I could be, some of you might be saying, well, we don't get any. If you don't get any, you're probably being hacked. But you guys all know that we're preaching to the choir. Information security is a big data problem in and of itself. So how many people here are consider themselves in big data analytics, the regression and stuff like that? So I am getting some of you. That's good. So this would be a problem. So what am I doing here? What are the problems in information security that can be helped by big data analytics? I use those terms interchangeably. And what are the problems you're going to run into? And what is big data? And I put no really there, because I run into a lot of people that say, especially outside the information technology, we're a big data firm. We do big data. We have big data. And you say, what do you mean? And they say, well, we have 2 terabytes of data in our database. And I'm like, well, that's not big data. That's just a big database. That's not what it means. Companies have realized this, some companies. And what they do is, a lot of times nothing, but a lot of times they put on a new front end and say, we're a big data company. And if you actually pushed on what they're doing, they've done the same thing for, they've had updates, but they've done the same thing for 20 years, for 15 years, where or for 10 years, where they came out with a product and the product deals with a lot of data. And they do what I first heard this term used in cloud computing, where every company said they were a cloud computing company. You guys obviously remember that, right? And it still exists somewhat to today, where they're saying, oh yeah, we're cloud computing. And you go, what do? Well, we provide updates online automatically. And I'm like, well, you've always done that. And do we do any work in the cloud? No, you download it to your servers. So we do everything at the server level, but you get updates on the cloud. And so that's a colleague of mine, of ours, not myself, came up with the term cloud spray, where they would take a product that exists already and cloud spray it and say, we're cloud now. And the same thing is happens with big data. It took me a real long time to make that paint can, but they take an existing system that uses a lot of data, and they say, I'm going to say it's big data, and the marketing department says, say it's big data, say it's big data, and so zing, I'm big data without doing anything, and so you do run, or sometimes with a minor change on the front end, or something like that. It's for marketing purposes, but it's not big data. And because a lot of people don't know what big data is, especially at the C-level executive area, they say, oh, okay, we're big data now. And so they're not lying when they say they're big data. They don't know. So the problem is that businesses generate terabytes of data, but it's not just that. The analysis burden that we're doing increases, right? Because have you ever known a PCI DSS to remove requirements, right? I mean, so they don't say, oh, okay, you don't need to do that anymore. That was 5 years ago. They don't say that. So all they do is add. HIPAA just adds. The SOX just adds. Your own systems tend to grow. You have controls that you're adding on to them, right? So we did have 200 controls that you had to verify last quarter. Now we have 300 this quarter. Okay, so the result is that we have increasing notifications, and I'm going to bring up an old problem with a different lens. Do you increase your staff size when this happens? And a lot of you raised your hands when you're hiring security people. By the way, I might want to talk to you. I've got some students, but a lot of times the security staff is not increased. A lot of times that's because we can't find anyone. And I'm going to bring up that problem at the end of the presentation on why that is. So the SEIM, SIEM systems are overlaid. I saw, I had this SEIM all the way through my presentation, and then I started doing some research on some products, and everyone called it SIEM, and then I switched it, and then I just found some research in some other products that call it SEIM. So just SIEM or SIM, but the SIM systems are overloaded. So let's talk about Target, because we're all familiar with it by now. Okay, so Target, these quotes were from Molly Snyder. So these were, to me, she is not an information security. She's more of a spokesman marketing role. But they were amazing, first off, that she knew this and that she actually said it. So they said, there are a vast number of technical events. So a lot of us are in this problem. There are a ton of events that are triggered by our software. Okay, so, and then what do? We don't have enough staff to track all the events. So we triage because we need to, right? So we triage the events. These ones look really important. These ones I need to look at some point, and these ones I'm going to throw away. Okay, so we triage all the events because there's too many events from our intrusion detection software, our IDS, our SIEM software, and so Target actually had a pretty robust system. They really invested a lot of money into it, and we're recently certified as PCI compliant. Some of you know that the PCI compliance can be revoked by PCI retroactively, so they could say, when you get hacked, oh, you're not PCI compliant, even though we said you were. But I don't think PCI did that to Target yet. They did it to TJ Maxx, where they just said, you pretty much lied to us, so you were never PCI compliant. And then they can retroactively fine you. So it does get into a problem. Now, FireEye was allegedly installed. From what I've read, FireEye refuses to confirm or deny their client list, which is probably good for FireEye, right? And I'm going to say if they were installed, whatever was installed, ArcSight or FireEye or whatever, they did a good job. They actually caught these errors, put out incidents, 5 of them on November 30th when the attack first happened, multiple ones, I couldn't get a number, on December 2nd. And so they actually had these, and they were investigated by Target employees. But the Target employees worked too much data. Okay, so they had too much data. So this is where I say this is maybe a big data problem, but it's definitely not big data. It is people being overwhelmed with lots of data without a good way to answer the problem of what do you do. And so the auto delete was turned off, which most of us do, and that's reasonable, right? Because we don't want to say to the software, oh yeah, delete those files that you detect. There are a lot of false positives. You would rather have the software detect everything than miss a detection, and as a result, you move the software towards over detection. The software companies do this themselves, towards over detection, and so that you get a lot of things that are reported as incidents that aren't incidents or aren't severe incidents, and that's what happened here. So I bring this up because if the Target employees were sitting around doing nothing and incidents all of a sudden popped up, then they'd be like, oh, we got to investigate these. We have incidents. That's not what happened. They were running around every day investigating hundreds of incidents, right? So some of you might be in that situation right now where you're investigating incidents all the time. You only can work a person 40 hours a week. They won't let you work them more than that. I mean, you could say you have to work 50 this week or something, but pretty much only 40 hours a week. And so they only have so much time to do what they need to do to investigate these. So you're burdened by this. And so they had too many alerts to investigate. They triaged and put things in a priority, and the Eastern European, Western Russia hacks that came in went not undetected, but unresolved. Now, when you read the popular press, even in the security journals, they say the system that Target had, the FireEye system, I think, was ignored, and Target ignored it. And I'm like, that's not quite the story, right? So that's why I say Target employees did a good job. They just probably were overworked and probably had to treat it out of necessity. So they didn't ignore it. They weren't sitting at their desk going, another incident, forget about it, I'm taking a long lunch. They weren't doing that. They investigated what they could when they could, and because this was a zero-day attack, they couldn't do what they needed to do on this. It wasn't flagged as important as it should have been. Okay, so what happened? And this is where we're starting to get some changes. Not enough, but we're starting to get some changes. The CEO did come out and say some pretty weird stuff. I don't think the CEO lied. I thought Target actually handled the situation pretty good, but he said some pretty weird stuff that was mistaken, wasn't true. Like I said, I don't think he lied. And he ended up being resigned, and so did the CIO. Now, a lot of our CIOs are not security specialists, right? I mean, because you good at technology doesn't make you a security specialist. We preach you to the choir, I think, on that one. But you're not a security specialist if you're a CIO. You're responsible for a lot of things. CIO was fired, CEO was fired, and people backed up a little bit. That and the OPM hack where Archuleta got forced to resign under heavy pressure, right? Where the top secret applications were leaked to, we think, China. That sort of thing is making CEOs and C-level executives stand up and say, wait, we need to do something about this. I could be fired. So we did. So this actually, there's a silver lining here, because it used to be security was, okay, you security people, go into your corner, do the security thing, and leave us alone. And then they, once every 6 months, pull in the CISO and say, okay, we got hacked. We trusted you, and you didn't resolve the situation. You're fired. Bring me the next person in line, and we'll make them CISO or hire outside. And to the point where there were even jokes about CISO standing for career is soon over. So this was the problem. But now that the CEO is on the line, they're starting to get boardroom reports. They're starting to get a little more interest in the topic. And this bottom quote was something that we're going to address. When I say starting to, I really mean starting to. A lot of companies haven't done it yet. There's a reluctance, there still is, but not at Target, to tie data breaches to the bottom line. So in other words, you security people are an expense. And you don't help my revenue at all. The cheaper we can do it, the better off we are. And they're starting to say that might not be a good way to live. And like I said, starting to, not done. So I make the point that we are all target here, because we all have overflowing incident response reports from our SIEM software that we have to respond to. And we don't have, a lot of times, the manpower, so we all have to triage. And when we triage, there is a chance, especially on a zero-day attack, there's a chance that a zero-day attack gets moved to a lower importance level. Okay, so that's where we're at. And so that's one of those. If you look at Target, I was looking at Target and saying, what could have they done? And to tell you the truth, even now, I'm hoping that the big data solution is a solution. I think it is, but the problem that we're having is that Target, if it happened today where they had another zero-day attack, what would they do? And they would try to triage it and see how important it is and then move it. I mean, what would they do differently? So we fire the people, but we don't change what we do. Look at OPM, if I pick on them a little more. They fired the director of the Office of Personnel Management for the US government, and they replaced her, and she came out and said, okay, we're now doing two-factor authentication to get into our systems. And I'm like, that's great, that's good. Two-factor is always better than one-factor, but that doesn't stop what China did. I mean, that doesn't stop anything. And so my guess is she's saying that because Congress is saying, what are you doing? And she says, two-factor authentication. And they go, okay, great. Because they don't want to say, I don't know what that is and how it relates. But yeah, so I was listening to the report and saying they fired the person who found the error. Now, granted, there was some, they had Einstein installed, and Einstein claimed they found it, and later they came out with someone else found it. But whatever, found on her watch, and they fired her. They brought someone new in without changing what they did. Okay, and so that's the problem that I'm having. So will the same thing happen again? Well, maybe, Okay, so now let's go into what is big data and big data analysis. And a lot of times I use data analytics and big data interchangeably. Someone might be, some of you big data specialists might want to come up to me afterwards and going, You can't use those interchangeably. But I do use them interchangeably because I look at this as big data and data analytics as the same thing. Okay, so we work with huge data sets, but the goal of big data analysis is not that you work with them, but to find out things you didn't know, that you didn't know to ask about. So if you're a security specialist and you know enough to ask about something, it's not a 0-day vulnerability anymore. It's probably a 2-week vulnerability, right? I mean, by the time you know enough to say, hey, are we protected against this? It's too late. So that's the problem. The way you do this is really statistics on steroids. So how many of us have taken a regression in the last 2 years? And that's a rhetorical question. But if you have never taken a regression in your life, you really can't do big data. That's the low bar, the entry point. If you look at some of the neural network approaches, some of the idea that people are typing things in and it's not in your database. So the big data specialists really take and by the way, I don't count. I teach it, and I do count myself as a very knowledgeable in the field. But the ones who do it for a living really take their hackles rise up a little bit when you say, "Yeah, we do big data. I have a database full of data." Because if it's in a database, we're pretty good at that. Pretty good at terabyte-sized databases already. So the idea from now is, what if people type something in? What about log files? What about a length of time that you're spending on a system? All these data sources that we're accessing now are not database data. You can't do an SQL statement and retrieve them with as easy as you can with a database. So there's a lot of data coming out there. The data is huge, and to analyze it, to make decisions on security or retail or whatever, it takes more than just accessing the database and doing an order by on your select statement. Okay, so that's the point we're making here, that you still need to know SQL. You still need to know some development, but you probably need to know a lot of statistics or be able to use a stats package. You've got to be ready for things that are not in a normal distribution. You've got to be, how do you adjust that? And so things like that, the complexity of the data is way larger than it used to be. Again, go back to the target hack. A flat file stored on the system, I think in an area not mapped by the file allocation table, where a RAM scraper was used to populate this, that was installed on the cache registers, and then leaked out slowly into another server in Eastern Europe. Leaked out slowly, so we didn't have the problems that we have before. So if you look at your IDS system right now, your intrusion detection system right now, they typically have, and by the way, not a bad idea, but they typically have a baseline where they measure what your network traffic should be, and if your network traffic exceeds that baseline by a 95% probability, right, that you're given this baseline and our average every day, and all of a sudden you get something way over here, or way under or way over here, you end up with an alert saying our network traffic's too high. So a lot of these packages try to keep under that radar. And so that's what they're doing. So what we're doing, the statistical analysis that they're doing, is just a confidence interval, right? And they choose the confidence interval, and they say, it seems unlikely that the network traffic should be this high. So if I want to grab data from you, I take it in smaller chunks, right? That's the game. And that's what they did at Target, I think. No one from Target called me, by the way. I tried to get as much information I can, just researching it, but that's but no one called me on this. But anyway, so the idea is you have this decision software, And then you have to convey this complex and sometimes very hard to understand analysis to decision makers. In normal big data analysis, those decision makers are the marketing department, the CEO. In your case, it would be this incident response that we're doing these high-level mathematical functions on a lot of times, technical functions too. They convey this to you in a way you can understand it and act quickly on. So there's the key. Okay, so we do how big is big. There's record sources, and I grabbed this from a normal data analytics slide. But for you guys, I know that I've seen the CERT presenters before a couple of weeks ago when they were talking about that were right before me. They were talking about some of the CERT tools that they use to grab data, and we end up with tons of data, right? Every time anyone gets data from you, we record their IP address, we record the length of time of their session, we record what port they were accessing, and you know, we have literally hundreds of thousands of hits, sometimes per hour. So you end up with a large data set. And you recognize the pattern. So this is the key big data right here. Can you recognize the patterns? And for information security, can you recognize the patterns that you don't know enough to ask about? The zero-day vulnerability. Okay, so you don't know enough to ask about them. All right, so the old way, and this is where I try to bring up old versus new, and this is from me, not from anywhere I picked up. So this is how would we do things differently? How do you stop target? And so the old way, signature recognition, check your server file, some file exists, and check some with the files, certain files. Probably not all of them, but some of them. What files do you have on your system? What are their dates? What are their file sizes? Run a checksum to see if they're changed. Network traffic, IP addresses on the network traffic, length of time of sessions, things like that. List of bad websites. How many websites are people going on internally that they shouldn't be going on? To see if anyone's internally a bad actor and trying to leak data from your company. And so that's the old way. And by the way, you still need to do this. Okay, so this is not, when I say old versus new, I really mean, hey, don't stop doing that old way, but you might need to add to it. The new way, unknown patterns, the zero-day vulnerabilities detected. New methods of hacking stopped. Again, if someone comes up with something new, that you stop it without knowing what it is first. And then different techniques, statistical analysis, artificial intelligence, expert systems, neural networks, things like that, which require a skill set that you might not have in your information security area or in your entire IT area, right? So the skill set that you need might not be there, and you might need to find a way to get that. So that's what I'm doing. Now let's talk about what I look at as some of the. There are some people doing big data analysis and big data using big data tools, doing a real good job. But I divide, and I'm not. I actually took it somewhere, but I don't remember where. I divide the big data and data analytics into three areas, where you have a visualization, decision support, and information discovery. So those three areas. So the information discovery would be the idea that we have this information. What are things that we didn't know before about this information? Then the decision support is, if I had 1,000 of you and I gave information to all 1,000, what would you do on all 1,000 cases? So in other words, you don't have the time. So there's software there, expert systems that mimic what you would do to report this. And then visualization is this idea that once we decide something's questionable, we decide something is definitely a threat, we turn it off, right? And that's, a lot of you are unwilling to do that, and I am unwilling to do that as well. but we need to get to the point where we are willing to do this. We talked to the previous two sessions all brought up that we're going to have to automate some things, right? Now, I know that there's questions on what you can automate and what you can't automate, but we can't be there all the time. We have to automate some things. So you have the things that are not a threat, because you would look at them and you would analyze them yourself and say they're not a threat. And then things that are a threat, you've seen it before, or yeah, it's doing some very weird things, shut it down right now, and what you would do, right? And then things that we don't know. And those are things that the visualization reports to you so you can make a quick decision. Now, the problem we have, going with the big data spray that I talked about, is that the visualization we are really good at. Okay, so we used to get reports, and we still get reports, but we used to get reports that were the previous night's activities, and we would read the reports, and even a checklist on paper, sometimes on the screen, and we'd go through the checklist and fix what we need to fix. Okay, and that's gotten a lot better. There are a lot of tools out there that say we're big data, and what they mean is that they are visualization. Is that bad? And the answer is, it's not bad to have visualization. It allows you to look at a bunch of data in a more compressed format instantaneously and make decisions right away. So visualization is not bad. It's just that that's all they're doing. So that's all they're doing right now. And so there are some other companies, but the visualization part is the problem, in my opinion. That when you say you're big data and you come out with visualization and you don't have discovery or decision support, then you run into problems. Now, I highlighted some things on decision support and information discovery. Some of us are pretty good at SQL Server already and ad hoc queries and things like that. A lot of us can do a SQL statement, without much problem. The OLAP might be a little bit different, but it's still a database issue, right? Where instead of having relational databases where data is related to other data, you relate every single bit of data to every other single bit of data into what's called a cube, and then you find the relationships that are kind of outside the normal bounds. So, are long connections typical in your company? Yes, they are. Are long connections to California at 2 p.m. typical company? And that's when they say, hey, this is weird. We don't normally have this. Whereas you, the manager, wouldn't say, well, yeah, we have long connections. I can't say every time someone has a session that lasts 20 minutes, but California 2 o'clock, long session, weird. So it flies under the radar of most IDS. But the big data analysis, the OLAP, the idea that you find relationships that don't exist, would pop it up and say, you never had this before. And then you say, oh, wait, there's a nation state that is trying to get the data and pull it in. Okay, and then the other two things I wanted to bring up were, the other things. So we understand that the data mining neural networks, if you're not using those, a lot of times a neural network finds relationships but doesn't tell you why. And I always use the example that the population of sperm whales in the ocean versus the stock market, right? The population of sperm whales is negatively correlated, but there's no causation there, right? So a lot of times neural networks come up with spurious relationships. The statistics, though, is important. That if you're doing this on your own, you have statistics that you have to employ, and usually you can't just, do an average. You have to do more high-powered statistics, and that takes a skill set that a lot of us don't have. The artificial intelligence and expert systems are important. It's the idea that you map what the rules you are using in your head into the software, so you can have many U's running around on your software and do exactly what you would do. They don't have to be intelligent, even though it's called artificial intelligence. They don't have to be smart. They just have to do exactly what you would do. And then the third thing is to customize software. You might need to develop some customized software. Okay, so I bring this up that we do a very good job of visualization, okay on decision support some of the time, and information discovery, a lot of times we leave that completely out on big data packages. So a lot of times people say we're big data, and we have a big data package, and you'll say, well, what are you? The Tableau and ClickSense and things like that are very good at visualization, but they expect you to provide the back end. You'll make bad decisions if you don't do that. So Google came up with this idea of MapReduce, where you take a database and reduce the information. Okay, and this is the idea, and they give the example where we're trying to find stuff about John and put it into a database. So we have this unstructured data. The MapReduce takes out patterns in the data, reduces it into a database, and ends up with the result. There's a package called Hadoop. It's Java-based that uses this. It looks kind of like a zombie attack, right? Except in this case, you're doing your own zombies. And the idea here is that you have all this data, and there's no way a server, a computer, one can run through it. So you end up with these slave computers, data nodes, that you say, you do this part, you do this part, you do this part. It's distributed computing, and you have to like a zombie attack is, right? When you get attacked by a zombie attack, and then the data ends up in a database. This is very intensive and technologically expensive, somewhat. So you need someone to manage this, and it is Java code. A good Java programmer should have no problem with this, but the Hadoop file system, that's the tough part. So setting up Hadoop is real tough. After you get it set up, I'm not saying any programming's got its issues, right? But then after you get it set up, there's Java libraries that Hadoop provides. Splunk is a vendor here, and I'm trying to bring up Splunk because they are the log file king. Although if you tell them that, they say, "Hey, we do other things," but and they do. But they analyze all your log files, which are pretty much unstructured data that's not in your database, registry entries, database logs, things like that, configurations, and they put it all together where the customer data, the outside the data center data, the RFIDs, the blogs, things like that, the alerts, the Kerberos tickets that you're putting out, things like that. They analyze all this. And they put it into a bundle of server where they actually take the data and make it accessible with a REST or SOAP interface. This is where I said, do I put REST or SOAP in here? And I thought, it'd be boring. So if you want to read about REST and SOAP, go Google it. But the REST and SOAP interface is XML output comes back at you. And it allows you to do alerts and things like that. They do have tools. Like this tool right here says what's running and what programs are running and what do they put out, what data do they put out. So they do have tools on Splunk. I know that Barclays was using, I think, FireEye again, but and other SIEMs, and the person in charge of this came out as a evangelist for Splunk and said, we are actually replacing FireEye, which I don't recommend, by the way. We are replacing FireEye because they trained the Splunk system, because neural networks and big data have to be trained to recognize things, situations that are bad. So they trained it using the FireEye output with the eventual hope to remove FireEye. According to the Barclay executive that was doing this, he eventually took a job with Splunk and left Barclay. So I always go, wait a second, did those talks come before or after you started being an evangelist? So take it with a grain of salt. But he seemed to be very, very pro Splunk. There are others that say that their incident response went down to 20 seconds per event on average, rather than 2 minutes is what they had before. That was WordPress. Now, this is going to be probably the last slide, but this is probably the one that you all care about. How much money are we making? 2 days ago, I went onto Indeed.com and said, how much are all these jobs paying? Okay, and I'd search for information security and big data. Now, I did some similar things with InfoSec and CISSP and data analytics and things like that, and got similar results. The blue section is 20 to 55,000. Notice there is no blue section on big data. These are full-time jobs that are paying 20 to 55,000. So the lowest paid was 20,000. I think the lowest I could find on big data was $65,000 a year. And so the problem with implementing big data is a lot of executives look at data analytics as helps revenue, not in security, but in, when we're trying to do it. And they look at information security as it's an expense, like I was saying before, like Target did. And they haven't changed as of 2 days ago. So they still are saying, you don't get the brown section is the highest paid, the 100,000 plus. You get half the big data jobs are 100,000 plus, less than a quarter of information security are. And so they say there's an information security shortage. And the reason for that is they're not willing to pay people to take up the skill set. And it's kind of a risky job. You get hacked. If I'm a developer, you're not going to fire me. You're just going to say, hey, develop faster. But if I get hacked, you might fire me. So that's the problem that we're having to implement this. Executives need to change their mindset. So you guys go tell your executives to change their mindset and see what happens. But that's the problem that we have. And again, IT security tied to expenses, and information security. Information security tied to expenses, and big data tied to the revenues a lot of the time, and so expertise in big data is harder to come by. Okay, and so the idea here is if you can't afford it, there are other companies that are incorporating big data in their solutions, doing the learning process on their servers, and sending you the finished product. And I listed a couple of them. IBM also has one. If I left your company out, sorry. But there are some other companies that say they're doing intelligence, big data, data analytics, and when I look at it, I can't find any that they're actually doing. They say they are, but I couldn't find it. But these, I know Cylance has a 99% detection rate, according to them, of zero-day vulnerabilities. That when they get a zero-day vulnerability, and then they just turn it off. They don't let you run it. So that seems to be a very good way to do it. So if you can't afford it, or then try to look for someone who will do it for you and send you updates on your system, and you'll get the database, nice structured data from them, and they'll deal with all the messiness of the big data. Okay, and I think that's it. Are there any questions? Okay, well then, I guess it is approaching lunchtime. So anyway, take care, guys.